All of the aircraft at MAKS are on display for everyone to see up close, with the exception of one, because the stealthy design of this next jet makes it very hard to detect. The PAK or T50 is Russia's 5th generation fighter. The supersonic jet made its second appearance at the MAKS airshow, but this was the first time that the media were able to get a slightly closer look. The aircraft is radically different from its predecessors. As well as being faster, more intelligent and manoeuvrable, scientists have worked hard to make it as stealthy as possible.
The Design Bureau, which is part of the United Aircraft Corporation, works very closely with various research centers of the Russian Academy of Sciences. For example, we've been working together on this 5th generation fighter jet, and I believe produce something that is on a par with the best models in this class worldwide.
The PAK is the embodiment of the fusion between theoretical science and practical application, and is one of only a few 5th generation fighters in the world.
We've got competition from China, and Japan has also announced that it's going to develop its own 5th generation fighter. But so far, neither China nor Japan have presented any working prototypes of their aircraft. So the only jet that can be compared to the T50 is the F-22. Generally speaking, these two planes have a lot in common, but only time will show in what way one is better than the other.
The PAK is a stealth aircraft. Particular attention has been paid to the leading edge of the wings, which has been staggered, the weapons bays, which have been concealed, the jet turbine blades, which have been covered, and the air intake, which is S-shaped. And those are just the bits we can see with the naked eye. The plane must also be shielded from external interference, whilst also emitting signals of its own without being detected. With military planes being so well protected against electronic interference, I bet the pilots don't have to turn off their mobile phones when taking off and landing. Military conflicts often act as a catalyst for scientific advancement. This is especially true of the radar, which first proved itself as a viable means of anti-aircraft defence at the end of the Second World War. Since then, radar and plane developers have been trying to outmaneuver each other to get the upper hand on the battlefield. A simple radar system is made up of a transmitter and a receiver. The transmitter emits radio waves, which bounce off an object, such as this aircraft, and are picked up by the receiver. Military radars can broadly be split into two types: detection and search, and targeting radars. Detection and search radars scan a wide area once every 15 to 30 seconds and operate on long radio waves. They are used for early warning systems and surveillance. Targeting radars, on the other hand, scan a much narrower area several times a second and are used for missile guidance systems and target tracking. But it's not all doom and gloom for the aircraft, however. There are a number of ways that a plane can reduce its radar profile to that of a small bird, or disappear altogether. But it's not as easy as you might think. A pilot can hug the ground to hide the plane in the natural relief of the terrain, but this makes flying much more dangerous. The shape of the plane can also be adjusted to scatter radio waves in any direction apart from back to the receiver, but this can seriously reduce the manoeuvrability and speed. However, there is another way. Unfortunately, it's not as simple as just changing the colour of the aircraft. The coating has to be totally redesigned on a molecular level. ONP Technologia is located in Obninsk. The company not only conducts research into composite materials and nano coatings, but also focuses on their real-life application in the aviation industry. Composite materials such as carbon fibre offer numerous benefits over those traditionally used in aircraft, and that's why the PAK is full of them. To make an aircraft out of carbon fibre, a mould must first be made. The company uses milling machines carefully to cut the mould out of wood. It is then finished by hand before being sent on to the next stage. Layers of fiberglass and carbon fibre are placed on the mould, which is then sealed in a vacuum bag. Tubes attached to the bag simultaneously suck out the air and infuse the mould with resin. The seal is constantly checked to make sure there are no imperfections in the finished product.
About 70 or 80% of the fighter jet's body is made of composite polymer materials, namely carbon fiber. We're now working on modifying the composite materials with carbon nanotubes, which will help further improve the durability of the components. At speeds of over 1,000 km per hour, metal wings start to deform, but CFRP ones don't, which allows the plane to move at higher speeds. Carbon fiber composite components also significantly decrease the visibility of the plane, making it a stealth aircraft. And Russia has been quite successful at applying the stealth technology.
As well as manufacturing composite aircraft components, the company also specializes in producing multifunctional nanocoatings. A number of institutes around Russia have been developing nanocoatings for aircraft canopies, but unfortunately they didn't meet the high standards required for the latest jets. The canopy of any combat aircraft must protect the pilot from electromagnetic radiation, the sun should not contribute to the plane's radar profile, and must of course be as transparent as possible. This lab has managed to develop one that meets all of these requirements. And it's applied in this special vacuum chamber. The canopy coating is made up of indium tin oxide and gold and is applied in a process known as sputtering. Layers of indium tin oxide and gold are applied in turns using an ionization process to build up a coating just 10 nanometers thick. But I'm afraid that's all we can say. The exact makeup of the coating is a secret.
Our coating makes the surface 40 to 60% less detectable by radar and 5 to 6 times more resistant to abrasion. This provides a huge advantage in the field. It is also much more transparent, which reduces reflection from inside the cockpit, enabling the pilot to see the runway lights more clearly.
Unfortunately, we weren't allowed to film how the coatings are applied to the other aircraft components either, but it isn't dissimilar to painting a large civil airliner. The coatings contain ferromagnetic nanoparticles, which are known for their radar-absorbent properties, but they aren't just applied evenly all over the plane. Different radar-absorbent coatings are applied to different parts of the plane in varying thicknesses. This attention to microscopic detail can give potentially huge benefits in the flight and stealth characteristics of the aircraft.
Russian designers say that while fourth-generation fighters using almost fifth-generation technology showed up on radar as objects the size of a football, the T50 shows up on radar as an object the size of a tennis ball. So you can see the progress that we've made.
Once the composite components have been produced and the nanocoatings applied, their radar signature is tested in this anechoic, or echo-free, chamber at the Institute of Theoretical and Applied Electrodynamics here in Moscow. The chamber is completely covered in radar-absorbent material. The height of the sponge pyramids corresponds with the frequency of the electromagnetic radiation. The climate inside the chamber is controlled, and all the equipment is built on the same foundation to prevent any vibrations from affecting the readings. And this is how it works. The electromagnetic wave transceivers are located at the bottom of the chamber. The waves are directed towards the mirror, which converts them into plane waves, simulating the effect long distances have on radar signals. The radar behind this nose cone detects which signals are let through. The rest are scattered about the room, and some are reflected back to the mirror and picked up by the transceiver, which gives an indication of the nose's radar profile.
It's impossible to make the effective surface of a plane equal 0 and render it invisible. What is possible is to minimize the distance at which it is detected, and that's the aim of stealth technology.
The chamber is so sensitive that it can even measure the radar signature of a ball bearing with a diameter of just 1 millimeter. This is partly thanks to the giant parabolic mirror that has a precision of 30 millionths of a meter. The star shapes reflect any distorted waves hitting the edge of the mirror towards the walls to avoid any erroneous readings. The maiden flight of the PAK-FA's predecessor, the Su-27, took place 30 years ago, and the updated versions will still be in service in 30 years' time. So with such attention to detail and high technology going into the stealthy PAK-FA, I'm sure this isn't the last we'll see of it either. Or is it?